Module 5. Capturing sensor data to the micro SD card. In this module, we will learn how to capture sensor data to the onboard micro SD card. We will also modify device configuration files to control our data capture behavior. Finally, we will use Python scripts to plot the captured sensor data. We will start by formatting our micro SD card. Insert your card into your PC. Launch the SD Card Formatter application. Make sure your card drive is set correctly and that the formatting option is set to Quick Format. Click on the Format button, and when the prompt appears, click on Yes to confirm. Once the formatting is complete, confirm that the card is now using the FAT32 file system with a 32 kilobyte cluster size. Click on OK to close this window and then exit out of the application. Safely eject the micro SD card through the System Tray or Windows File Explorer. If your STWIN.box is not plugged in, connect it to your PC now. The red LED will blink rapidly, indicating that the board is properly powered. The green LED will blink approximately once every 2 seconds to indicate that the firmware is loaded and ready to start capturing data. Carefully insert the micro SD card into the STWIN.box. The orange LED will now turn on, confirming that the card is properly detected. Reset the STWIN.box by pressing the Reset button. Once the green LED resumes blinking, press the User button to start the data capture process. We will run the capture process for 30 seconds. The green LED will start blinking once every second, indicating that data is being read from the sensors and written to the micro SD card. Press the User button again after about 30 seconds to stop the capture. Once the green LED resumes blinking every 2 seconds, remove the micro SD card from the board by pressing into the card to release it from the slot. Reinsert the card into your PC. Launch a File Explorer window. Navigate to the root directory of the card and you will find a single folder called STWIN.box _00001. Open the folder and you will see the captured sensor data files and associated JSON files. As in the previous module, we will edit the device configuration file to customize our sensor capture parameters. To set a default capture profile, copy the current device configuration file to the root directory of the micro SD card. Open the device config file by right-clicking and selecting Edit with Notepad++. For this exercise, we will only be capturing data from the ISM330 accelerometer. To disable all the sensors, press Ctrl-H to open the Search and Replace box. In the Find What box, type "enable "space true." In the Replace with box, type quote enable quote, colon, space false. Then click Replace All. This should replace 10 instances, turning all sensors off. Close the search box. We want to use an ODR value of 104 Hz again, so scroll to line 196 and set the ODR to 3 as referenced in our table. Let's utilize the full-scale capability of the accelerometer by making sure the FS field is set to 3. FS field equivalent values are referenced in the following table. 2G would have a value of 0, 4G a value of 1, 8G a value of 2, and 16G a value of 3. On line 198, enable the accelerometer by setting the Enable field to True. Save the JSON file and exit Notepad++. Safely eject the micro SD card from your PC. Insert the card into the STWIN.box board. Reset the board by pressing the Reset button. This will clear any configuration information currently loaded on the device. We will be capturing sensor data with the board in 3 different positions, each for approximately 10 seconds. The first position is on a level surface. The second position is in the palm of your hand, with no motion. The third position is in the palm of your hand, with a slight rocking motion back and forth. Once the green LED resumes blinking, press the user button to start the data capture process. Leave the board motionless on a flat surface for 10 seconds. Next, slowly pick up the board and hold it still in the palm of your hand. Once 10 seconds have passed, slowly start moving your hand for a third 10-second capture block. Press the user button to stop the capture. Once the green LED resumes blinking at once every 2 seconds, remove the card from the board by pressing the card edge to release it from the slot. Insert the micro SD card into your PC. Launch a File Explorer window. Navigate to the root directory of the card, and you will find a new folder called STWIN.box _00002. As before, you will find the captured sensor data and associated JSON files in this folder. Rename this folder to STWIN.box _capture and copy it to the workshop directory. We will utilize this data capture folder in the next steps. We will now use the Python scripts to plot our captured sensor data. Navigate to the STM32Cube function pack data log folder. Open the Utilities folder. Open the HSD Python SDK folder. Open the Examples folder. Here you will find several Python scripts you can use with your captured sensor data. HSDataLog to NanoEdge will convert your captured data into a format that can be easily imported into ST's NanoEdge AI Studio for use in machine learning applications. The models generated by this tool can be run on the STM32. HSDataLog to Unico will prepare your captured data to be imported into ST's Unico GUI tool. This converted data can be used to generate machine learning core and finite state machine models to run in the onboard ISM330 device. HSDataLog to Wave will take captured microphone data from the STWIN.box board and convert it into the industry standard WAV file format. These files can then be played through any audio playback application. Today, we will utilize the HSDataLog plot script, which can be used to visualize previously captured sensor activity. In the File Explorer path bar, type CMD to open a command prompt window. Run the Python script by typing in the following command and then press Enter. Python hsdatalog _plot.py /stwinbox -data -log -workshop /stwinbox _capture. We only sampled a single sensor during the capture, so only one sensor device will be listed. Type 0 to select the ISM330DHCX, followed by Enter, to plot the accelerometer data. Notice the plot shows areas with varying ranges of motion and phases with relative stability. This is because data was captured while on a level surface during the transfer to your hand, and then while slowly being rocked back and forth. You can zoom into this data by using the magnifying glass button in the plot window. Close the data plot window and type Q to quit the Python script. Close the command prompt window. In this module, we learned how to capture sensor data and save it to the micro SD card. We also customized our data capture by modifying the device configuration JSON file to our requirements. Finally, we used the included Python scripts to plot the captured sensor data. This concludes Module 5.